Welcome to this SkillPad video resource, where we make learning fun. In this video we are going to look at voltage, resistance, and Ohm's law, or basically how electricity flows through a conductor, the resistance it has to overcome, and the law that explains the entire process. Imagine being in a pitch-dark room, struggling to find the light switch. You eventually find it, flip it on, and voila, the room is filled with light. Ever wondered how this happens? How does the flick of a switch light up an entire room? This mystery can be unraveled by understanding three fundamental concepts in physics: voltage, resistance, and Ohm's law. Firstly, envision electricity as water flowing through a pipe. Voltage, then, is the water pressure that pushes the water through the pipe. In electrical terms, voltage is the force that pushes charge through a conductor, like a wire. It's measured in volts, and is often referred to as the electrical pressure that causes electrons to move and thus create current. Now consider what would happen if there were obstacles the water pipe. The speed of the water flow would decrease, right? This obstacle is akin to resistance in an electrical circuit. Resistance opposes or resists the flow of current. It's measured in ohms. But what factors can influence the resistance of a conductor? It turns out that the length of the conductor, its cross-sectional area, the type of material it's made from, and the temperature all play a role. A longer conductor, or one with a small cross-sectional area, can increase resistance. Similarly, different materials have different properties that can affect resistance. For instance, copper is a better conductor than rubber. Lastly, high temperatures can also increase resistance, because the increased energy causes the atoms in the conductor to vibrate more, which can impede the flow of electricity. Here's where it gets interesting. The relationship between voltage, current, and resistance is given by Ohm's law, named after the German physicist Georg Simon Ohm. Ohm's law states that the current passing through a conductor is directly proportional to the voltage across it, and inversely proportional to the resistance. In simple terms, if you increase the voltage, the current increases. But if you increase the resistance, the current decreases. However, there are materials that don't strictly follow Ohm's law. These are known as non-ohmic conductors, where the current does not change proportionately with the voltage. On the other hand, conductors that follow Ohm's law are, unsurprisingly, called ohmic conductors. Now let's delve into semiconductors, which are components that can control the flow of electricity. They are neither good conductors like metals, nor insulators like rubber. Semiconductors show properties of both conductors and insulators. Semiconductors become less sensitive as their temperature rises, which is opposite to the way metals behave. At very low temperatures, such as 0 Kelvin, semiconductors behave like insulators, but as the temperature increases, they begin to work like conductors. The conductivity of the semiconductors increases when impurities are added. The process of adding impurities to semiconductors is called doping. Semiconductor materials are useful because their behavior can be easily manipulated by the deliberate addition of impurities. Semiconductor conductivity can be affected by the introduction of an electric or magnetic field, exposure to light, and exposure to heat. Therefore, semiconductors can make excellent sensors. They can be found in diodes, transistors, thermistors, light-dependent resistors, LDR, light-emitting diodes, LED, and potentiometers. Each of these components has a unique function and use, from regulating electric current to converting electrical energy into light. But remember, while Ohm's law is a fundamental principle in understanding electricity, it does have its limitations. It doesn't apply to components like diodes and transistors, or when the temperature isn't constant, among other conditions. In summary, the flick of a switch lights up a room due to the principles of voltage, resistance, and Ohm's law. Voltage is the force that pushes the current through a conductor. Resistance opposes this current, and its effect on the current is explained through Ohm's law. Understanding these concepts not only demystifies the workings of a simple light switch, but also forms the foundation for comprehending complex electrical and electronic systems. Thank you for using this SkillPad video resource. We hope it was enlightening. Come with us as we explore the world of science for your learning pleasure. We hope to see you again soon.